Good morning. This is Neil Polymus. I'm in charge of development here at Statgraphics Technologies. And it's my pleasure to talk today about some of the new features that we've put into release 19.3 of Statgraphics Centurion. Among these, primarily, are Trellis Plots. Trellis Plots are something that I've wanted to put in the system for a long time. And I've been excited that we were able to do it for release 19.3. It did require a significant amount of coding, since Trellis plots create more than a single plot on the screen at the same time, which is not something that we've actually done before. But I think after you see the examples I'll show you today, that you'll agree that it was worth the effort. Now, Statgraphics 19.3 contains several new features. The first, as I said, are Trellis plots. And I'm going to be giving you an example of several types of Trellis plots as we go through the webinar today. Trellis plots are also called lattice or panel plots. And basically, they can show different types of graphs for various combinations of other factors. Now, they are a significant addition to Statgraphics. And in the past, we might have saved them for a major release. But because Statgraphics 19 is licensed on a subscription basis, what we've been trying to do over the last year or two is to get new features out to people as soon as they're ready. So rather than waiting for some hypothetical version 20, we're going to put things in some of our more minor releases. And this is one, it's Statgraphics 19.3. Okay. We've also, in this particular release, added an additional data input option for doing cross-tabulation. And what I'll show you toward the end of the webinar is how you can use data in multiple columns now to do a cross-tabulation. We've also changed our academic site license activations so that administrators can use non-persistent virtual machines in their classrooms and laboratories. It used to be that if you had a classroom or a lab full of computers and you wanted to use Statgraphics, you had to activate it on each machine in the classroom. Well, what we've done is we've introduced the license manager into the activation process now, so that basically you can activate Statgraphics once and push it out to a whole room full of computers. It definitely makes it easier for IT folks, also easier to keep everything up to date as we add in the new features. Okay. Now, Trellis plots, which is the major subject I'm going to be talking today, are basically multiple plots arranged in a grid. And what they do is they show how some particular variable has changed based upon levels of either one or two conditioning factors. For example, this is a picture, some box and whisker plots of the car data file that I've looked at many times in these webinars. In this case, we're looking at miles per gallon in highway driving, conditioned on the type of drivetrain that a vehicle has, whether it's all-wheel drive, front-wheel drive, or rear-wheel drive, and also the type of vehicle. Is it a compact car, a large car, a mid-sized car, or whatever? And all of these plots are on a common scale, so it's easy to see, for example, that miles per gallon in highway driving is lowest in the vans, down around between maybe 20 and 24 miles per gallon, considerably higher in front wheel small cars. Here you can see a couple, they're actually labeled as outside points, couple observations pushing 50 miles per gallon. Now I'll be demonstrating this live, but that's the basic idea of a trellis plot. It's going to be some type of plot. It could be a box and whisker plot, could be a bar chart, could be a histogram, could be a regression curve, but it's displayed in a grid based upon combinations of either one or two conditioning factors. Okay, well, let's go and talk about the different types of trellis plots that we can create. The first type are plots for numeric data, like the one I just showed you, miles per gallon. And for numeric data, we're able currently to create trellis plots showing box and whisker plots, or histograms, or normal probability plots. Well, there are also plots for categorical data, things like the type of vehicle, for example. And for that, we could make bar charts or pie charts or donut charts, again, showing up in each section of the grid. We've also created trellis plots showing the relationship between two numeric variables, how y, for example, depends on x. And I'll show you an example of this in a couple minutes. And there you have the option of doing a simple scatter plot, or fitting a regression curve, or perhaps doing a non-parametric smoother. And then finally, in the latest release, which is actually 19.3.02, which we posted just last night, we added plots for z versus x and y. That's where you have one quantitative variable, which is a function of two other quantitative variables, and you want to see it at levels of different factors. And the choices here are bubble charts, regression curves, and LOES, locally weighted scatter plot smoothers. Okay, now I'll be demonstrating this, and if you want to try this final type of plot, you'll need to install the release that we put up just last night. That's 19.3.02. The other types of trellis plots were in previous releases, but Z versus X and Y was just added. Now, as I go through here, I want to invite you all to submit questions. I'm going to demonstrate these various types of plots. But then at the end of the webinar, I'll take a few minutes and answer any questions. And if you've used GoToWebinar before, which most of you have, you can see the facility for sending us questions. Okay, let's go now and actually create some trellis plots. Now, the first example I'm going to show you uses data from the World Bank. It's data on life expectancies of males and females in various countries around the world. We've looked at this data before in a slightly different way. The data, though, are for the years 1961 to 2010 and show the average life expectancy in a particular year for a particular country for a particular gender, male or female. Okay, now to actually generate this, I'm going to switch over to Statgraphics and do this live for you. Okay, now I've already loaded the life expectancy data into our data sheet, so we can go right ahead and do the trellis plots. Now, at the moment, the trellis plots are all located under Statlets. Under the data exploration section, you'll see the 4 types of trellis plots. Eventually, we're going to take trellis plots and integrate them into other procedures throughout the system. For example, there's a good application of trellis plots in designed experiments, So we'll integrate some of our Trellis plots directly into the DOE wizard. Okay, for the moment, though, they're all located under Statlet's Trellis plots. The type of Trellis plot I want to start with here is going to be numeric Y. I'm going to be looking at life expectancy. Now, the dialog box is going to ask me, first off, what is the dependent variable I want to look at? What variable has the data? And that is life expectancy. It's then going to ask me for either one or two conditioning factors. And I'm going to start by telling it I'd like to see life expectancy as a function of year. Now, when I do that, it's going to create a plot for me. And what you see is actually 5 different plots on the screen. By default, it's box and whisker plots. 5 different plots for different ranges of that conditioning factor. It shows me a box and whisker plot for 1960 through 1970, 1970 through 1980, and so forth. And if you look at the sequence of plots, you can see the boxes moving up toward higher values. Life expectancy has been increasing over the years. Okay? Now, by default, it's looked at year and decided it was a continuous variable. Up here on the toolbar for the Trellis plots, you'll see that it's checked continuous. You could override that and make it discrete if you wanted to. If I took off the continuous flag, it would give me a box and whisker plot for every year. That'd be a pretty crowded Trellis plot. Okay. I'll do something like that in a few minutes with different data. There's also a check box at the top, one row. By default, you see it took the Trellis plots and put them in 2 rows. But if you'd rather see them in a single row, you can just click that checkbox. And now you can see perhaps a little better the increase in the box and whisker plot toward higher life expectancies over time. And I should emphasize that the scales of all the plots are fixed, right? They're the same in every single plot. So you're seeing something you can easily compare. Now, up in the top left of the toolbar, you'll see that it's currently set to box plots. If I wanted to, I could switch either the frequency plots or normal probability plots. If you wanted frequency plots, it would give you, by default at least, a histogram. That's another way of looking at the distribution of life expectancy in different categories of year. Now, whenever you have a Trellis plot on the screen, you can also push the right mouse button and go to Analysis Options. And this will give you different types of options for a particular plot. Right here, for example, it's decided to create 43 classes between 0 and 100. I could override that if I wanted to. A little bit more interesting, though, is down at the bottom, it says density estimates. And by checking one of these boxes, I could add a smoother to the plot. For example, I could tell it I'd like to see a non-parametric smooth with, let's say, width 30. If I then press OK, you'll see that it's superimposed on top of each histogram an estimate of the density function, the underlying density function. Right? And you can see that they're definitely somewhat skewed in the negative direction. Most countries have relatively high life expectancies, particularly in the years 2000 to 2010. You can see the peak is over here, getting close to 80 years. But there are still, unfortunately, some countries in the world that have relatively low life expectancies, all the way down to about 30 years. Okay. Again, the Trellis plot is a very good way of looking at how the data change as a function of a particular factor. Now, next thing I'm going to do is I'm going to go back to the box plots. But now, rather than looking at the data just by one factor, year, I'm going to go back to the data input and put gender in as a second conditioning factor. If you put in two conditioning factors, year and gender, the first factor will be used to define the rows of the trellis plot, and the second conditioning factor will be used to define the first conditioning factor defines the columns of the trellis plot, right? That's year. And the second conditioning factor, gender, defines the rows. Now you can see how life expectancy has changed, not just over years, but between males and females. And you'll notice that, as we all know, females tend to live longer than males. And it's fairly dramatic. Okay, you see the box and whisker plot shifted to the right in every year category for the females versus the males. Okay, this is where the trellis plots, I think, really come into their own when you have more than a single conditioning factor. Okay, well, that's what we can do when we have a numeric variable like life expectancy. Let's load a different data set now and see what we can do for categorical data. Here, what I want to do is I want to load up a data file called World Bank. What we were looking at was, just a moment ago, was the subset of the World Bank data sets that shipped with Statgraphics. And now what I want to do is I want to look at a variable called fertility rate. Okay, fertility rate is the average births per woman in a particular year in a particular country. Now, to do a nice trellis plot on this, I'm going to go to Statlets, Trellis Plots, Categorical Y. Now, you'll probably ask, why is he going to categorical plots when fertility rate appears to be a numeric variable? Well, because what I'm going to do is I'm not going to look at the data just the way it is, but I'm actually going to round it. I'm going to type in the dependent variable field round fertility rate. So it'll round all the data to either one child, two children, three children, four children, or whatever. Okay. Then I'm going to tell it, let's condition on year. And what it will create for me is, by default at least, a bar chart. And again, I think I'll put it in a single row. And now what you can see is, rounded to the nearest integer, the distribution of the average number of births per woman across all the countries in the world in different categories of year. And what you can see is that back in 1960 to 1970, there were no countries that averaged just a single birth per woman. But by the time you get to years 2000 to 2010, there were starting to be quite a few countries where the average rounded was just one birth. So there was a definite change with time in the number of births per woman, and it was going down. I mean, back in the 60s and the 70s, there were countries that averaged 8 births per woman. Well, that has disappeared in this particular century. But again, a very interesting plot. Other options, incidentally, for categorical data would be pie charts and donut charts. I sort of like the donut charts. What you have is you have basically a section of the donut here where the angular distance is proportional to the number of observations. And it shows me, for example, that in the years 2000 to 2010, about 50%, about half of that plot, about 50% averaged between 1 and 2 children per woman. Okay, so that I thought was an interesting example. Now, the next example I want to look at has to do with the rate of COVID infections. I want to look at the relationship between the number of cases of COVID-19 that have been observed versus the percent of people that have been vaccinated. And I have an interesting data set here. It's called vaccinated. This comes from the CDC. And what it shows in this particular data file, the data, it ranges from every week in September, October, November, and December of last year, of 2021. For every week, for different age categories, for example, 18 to 49, and different vaccination statuses, like boosted, vaccinated, unvaccinated, how many cases of COVID-19 were reported in the United States? And also, how many individuals fit in that particular category? Now, the variable we're going to look at is a calculated variable over here. It's the number of cases per 100,000 individuals. And what I want to show you is the relationship between cases and week. Basically, how the infection rate has changed over time. Now, to recreate this trellis plot, we'll go to Statlets, Trellis Plots, Y versus X. The dependent variable will be cases per 100,000. The independent variable will be week. So that's the Y and the X. And now what I want to do is I want to condition this on two things. I want to condition it on age category. That'll be my first conditioning factor. And vaccination status, that'll be the second. When I ask for this trellis plot, it will by default give me XY plots. Week is the variable that defines the horizontal axis. Cases per 100,000 define the vertical axis. Each column of the trellis plot is an age category. People aged 18 to 49, 50 to 64, and 65 plus. The rows are your vaccination status, where individuals not vaccinated at all, had they got the primary vaccine, or had they got the primary vaccine plus a boost. Now, to make it a little bit more easy to see, I'm going to go to analysis options and also ask for a locally weighted regression to be placed on the data. And I have found that a smoothing fraction of 30 gives a pretty good smooth. What it's done is it's taken the data in each section of the Trellis plot and smoothed it. Now, what do you see? Remember, this data basically goes from September of last year through December, the end of December. The week numbers are the number of the weeks in the year. Well, what you see is that back in September, at pretty much each age category, okay, the number of cases was much higher for the unvaccinated individuals than it was for either the boosted individuals or the vaccinated individuals. Okay? It's just substantially higher. You'll also notice that throughout September and October into November, there was a leveling off, really a decrease in the number of cases amongst, well, probably everybody, but it's most noticeable for the non-vaccinated individuals. But then as we got into December and the Omicron variant appeared, the case rates started to take off for everybody, right? You can see that it started to go up dramatically, not only for the unvaccinated people, but also for the vaccinated people and the boosted people. Now, I had wished could have gotten data for the beginning of 2021, but all I could find on the CDC website ended at the end of December. But you can see that Omicron really took off, and there were obviously a lot of breakthrough cases. Not only did the case rate increase substantially for the unvaccinated people, but it did also for both the vaccinated and the boosted people. Now, the other thing you can see that's of interest is start comparing age categories. The case rates toward the end of the year increased dramatically, especially for younger people. You'll see the case rates went up somewhat for the 50 to 64-year-old people, but not nearly as much as for the 18 to 49-year-old people. And for those who were 65 plus, the increase was also not as dramatic. Now, what the reason for this is, I'll leave you to speculate. But you can see the Trellis plot does a really good job, I think, in showing you how things have changed and how they differ based upon the age of the individual and the boosting status. Okay, now that's a smooth scatter plot. I also like to show you some regressions, but this is not a particularly good data set to do that. I have another data set, though, also a COVID data set, which is actually a very interesting one to look at. It has the death rates, the rate of death per 100,000 individuals by state throughout the 50 states and the District of Columbia. This is actually deaths since December 13th. December 13th was when the Omicron variant really started to take off. And the data shows the deaths per 100,000 since December 13th. That's this column here. I also have a column which shows in each state the percent of the individuals, the population that was fully vaccinated. Okay. What I was particularly interested in was seeing whether there was a significant relationship between deaths and how many people in the state were fully vaccinated. And I also have another column out here because of some of the things I was seeing in the news that shows for each state who won the last presidential election. You know, we had a presidential election in 2020, and we know for each state whether they voted for President Trump or whether they voted for President Biden. That's an interesting conditioning variable, as you'll see. Okay. I was curious whether there was any difference between you hear a lot on the news, a lot of which is not true, which is why I wanted to do this particular plot. So let's do this. Let's go to stat. Let's Trellis plots, Y versus X again. Here I'm going to look at deaths per 100,000 individuals. That's deaths per in a particular state since December 13th. I want to look at the percent of people that were fully vaccinated in that state and also who won the presidential election. All right, let's press OK. Well, it comes up and it has decided, obviously, that the presidential winner was categorical. These are the states here who voted for Biden. These are the states here who voted for Trump. Okay. Well, this is a good plot where we can actually go ahead and do a regression. And I'm also going to go to analysis options, put in some confidence limits so you can see the regression curves. Okay, now, there is a suggestion in the data that deaths per 100,000 are inversely correlated with the percent of fully vaccinated. I mean, that's what a lot of people would have expected, right? The more people in the state that were fully vaccinated, the lower the death rate. On the other hand, you can see these confidence intervals. That's a confidence interval for the mean value of that line. And you could easily take that line and make it horizontal, and it would still be entirely in the green area. In fact, the p-value for the regression, I ran it through a regression, is 0.23. This relationship is not anywhere close to being statistically significant. And if you take this particular point here, you see this point here? Let me go up and choose tag and tell it I want to see what state that is. I'm going to tell it to label the points when I click on them by state. That's actually Tennessee. Tennessee, for some reason, has a much higher death rate, reported death rate. Let's qualify it, okay? A reported death rate than any other state. If you take Tennessee out of the equation, the p-value between deaths and percent fully vaccinated is about 0.4. Okay, not anywhere close to being statistically significant. Okay, which obviously raises the question about, is there any relationship between how many people are dying in a state and the percent of people that are fully vaccinated? It clearly is not statistically significant. I mean, look at that scatter. Look at the scatter. I mean, the slope is negative, okay, but at any normal p-value, we would not call that a statistically significant relationship. You can also see that the relationship is just about the same for the states that voted for Biden and the states that voted for Trump. Again, I ran that through the comparison of regression lines routine in Statgraphics, and it also said no significant difference between the Biden states and the Trump states with respect to the slope of that line. Looks a little steeper for the Trump folks, but that is not statistically significant. Anyway, it's an interesting data set. And by the way, I have posted all of this data on the Statgraphics website. I'll give you the link at the end of the webinar, but you can just go ahead, grab the data, and do this yourselves to see what you think about any significance or non-significance here. Okay. All right, well, there's one more type of trellis plot that I haven't talked about yet, and that has to do with Z versus X and Y. Now, this final type of trellis plot is very useful in looking at data from designed experiments. And what I'm going to do is I'm going to actually pull up an experimental design that we ship with Statgraphics. It's an experimental design in which there were 4 factors that were varied. The output variable is actually the reception quality of the TV signal in decibels. They were trying to see what combination of various factors would give the best reception. It's an experiment, a multi-factor factorial experiment, in which they took and did an experiment at 3 levels of filter tabs, 3 levels of sampling frequency, 2 levels of image bits, and 2 levels of voltage. It's a 3 by 3 by 2 by 2 factorial design. Now, I'm showing you here what comes out of this design of experiments wizard if you do the analysis. Okay? And what you see is a whole lot of significant effects. All 4 factors are significant, A, B, C, and D, statistically. Again, any bar to the right-hand side of this line indicates significance at the 5% level. There are also a lot of significant interactions. In fact, every interaction except for CD is statistically significant. There are also a couple significant quadratics here. AA, which is filter tab squared, BB, which is sampling frequency squared. Okay? So what you see is some highly significant effects. Well, the results of this experiment can be shown in a trellis plot. Eventually, we'll incorporate the trellis plot right into the experimental design wizard. For the moment, though, if I wanted to look at this data, I could go to Statlets, Trellis Plots, Z versus X and Y. Okay, now, the dependent variable for this data is the reception quality. The 2 primary independent variables that they were experimenting with were the filter tabs and the sampling frequency. Image bits and voltage were actually uncontrollable noise factors. What they did for the purpose of the experiment, though, is they controlled the image bits and the voltage to see what effect they would also have on the reception quality. Now, if I press OK, it's going to open up a trellis plot and by default do a bubble chart. What you see on this particular plot is each of the experiments that was done. Remember, there were 3 levels of filter tabs, 3 levels of sampling frequency, 2 levels of image bits, and 2 levels of voltage. And right now, we've color-coded the points according to the measured reception quality. Well, bubble charts are good when there's lots of data. More interesting in this data set is to do a regression fit. What we've told it here is to go ahead and fit a regression of reception quality on all 4 of those factors. Actually, by default, what it does is it does a separate fit in each section of the plot. So it did a fit of 256 image bits versus 100 voltage, and separate regressions for each. If I press the right mouse button, though, and go to Analysis Options, I can tell it, instead of fitting separate models for each section, do what we did in Design of Experiments, which was fit a single model to everything. And now I can specify what model I want. I'm going to tell it, give me a constant, give me main effects, give me curvature for A and B. Now, C and D were both at just 2 levels, so we can't do any quadratics for them. And then give me the significant interactions that I saw in the designed experiments, which was everything except CD. And now when I press OK, what it's done is it's fit one single regression model to all 4 factors and displayed it at various combinations of the factors. And it's easy to see that you get the best image quality down in this region here, right? The oranger it is, the better the reception quality. And incidentally, it's drawing contour lines at each level indicated over here in the reception quality field. So it's drawn a contour line at 0, one at 10, one at 20, one at 40, one at 50. But you can definitely see bad image quality down in this area and good image quality in this area. Now that's a regression fit, right? It's fit a parametric regression model, just like I would have done in design experiments. We have one other option here, though, and that's to do a Loess smooth. Loess stands for locally weighted scatter plot smoothing. That's a non-parametric way of estimating the height of the surface. And so what it's done in this case is taken the points, again, in each section of the plot and done a locally weighted regression. What it does actually at every point in each of the plots, it fits a weighted linear regression against the 2 numeric variables, in this case, filter tabs and sampling frequency, where if I'm estimating it at a particular point here, it's going to give most weight to the observed data that are close to that point and less weight to points that are far away. So if I'm estimating the height of the surface here, most of the weight is going to the 4 points in that vicinity. It's a locally weighted regression, a very popular way to estimate relationships without assuming any underlying mathematical model. Okay. Now, incidentally, if you want to do this Z versus X and Y, you need to download and install the build that we put up last night. Okay, the 19.3.01 build did not have this, but it is such an important feature that we wanted to get it in for you as soon as we could. All right, well, that finishes what I really wanted to talk about with respect to trellis plots. Now I need to talk a little bit more about the other features, and this will just take me maybe 5 minutes, the other features that were added to Statgraphics. Oh, incidentally, my slides here, all the slides I've produced for the webinar will also be posted on the website. Actually, they're already up there. I'll give you the link in just a moment. Now, I did mention that there were 2 other changes for version 19.3 that I thought you would be interested in. The first I wanted to mention was a cross-tabulation. A cross-tabulation is a procedure that takes two variables and basically counts how often those variables occur together. Okay. Now, in the past, we would always do a cross-tabulation by taking the data in two code columns, one for each factor. We've added an additional option, though, to take data in multiple data columns. Okay. Now, for example, the old way of doing it would have been this. This is the data from our car data file, two columns. One column is the type of vehicle, one column is the number of passengers. Okay, and there are 93 rows in that file. In the old way of doing things, I would have taken those two columns, had it go scan down through the data sheet, count how often each of the variables occurred together, and create that particular plot. Okay. And what you're seeing here actually is a Mosaic plot. You can see, for example, that compact cars tend to have to hold 5 passengers most of the time. Some do 4, some do 6. On the other hand, vans tend to have either 7 or 8 passengers. Okay. Well, we're going to produce that same plot with a different data structure, and the new data structure you can use is this. Instead of having two columns, one with the type of vehicle and one with the number of passengers, you can now create columns, one for each type of vehicle. For example, I could create one column for compact cars, one for large cars, one for mid-sized cars, and put each automobile, each compact automobile in the first column and type in how many passengers it holds. Okay, and we can create the same sort of cross-tabulation now from this data structure as we previously did from the data structure with just two columns. Looks like a minor addition to the program, but if your data happens to come that way, it makes it a lot easier than trying to take data like this and create code columns out of it. All right. And then finally, one more change to the program, and that's for all of our universities that have academic site licenses. We have a number of universities, quite a few all around the world, that have academic site licenses. That means that everybody at that institution, students, faculty, staff, can use the program. It's licensed for everybody. Well, prior to release 19.3, Statgraphics needed to be activated separately on everybody's computer. And that's fine for individuals, but didn't work very well in classrooms and laboratories, because there's a lot of interest these days in moving to what are called virtual machines, where the IT department basically uploads to each computer in a classroom or a laboratory some master image. And they didn't want to have to go around to every computer in the classroom and activate Statgraphics separately. So what we have done with version 19.3 is we've added a license manager so that the IT department, when they create the master image that's loaded into every computer in the classroom or lab, can just activate the program in the master image and not have to go around to every single computer in the classroom. And that was a change we put in for 19.3 at the request of a couple of universities. I think is going to save people an awful lot of time. It also means when we come out with a new release like 19.3.02, they just have to install it once in the master image, and then it's going to be available throughout all the classrooms and the laboratories. Okay. Again, it looks like a minor change, but if it's something you need, it's not so minor. It's definitely saves an awful lot of time. Okay, that's my webinar for today. As I said, we've posted the sample data and the slides for the webinar at www.statgraphics.com/webinars. Actually, the data and recorded webinars for all past webinars are on that page. And we've also been recording this webinar. And as soon as we can get it processed sometime this afternoon, this webinar will be posted on that website as well. All right, well, I hope you found that interesting. Let me take a look and see whether anybody has submitted some questions, and take a couple minutes and try to answer that questions. One question, are factor 1 and factor 2 weighted? I mean, is the order of the factors important? No. In every one of my lattice plots, you could have easily switched the order of the factors and nothing would have been changed. The only thing that you have to watch out for is, for example, some are independent variables, right? For example, in the last Trellis plot, there were 2 independent variables which defined the vertical axis and the horizontal axis. And then there were 2 factors that defined the columns and the rows of the plot. So the plot will look different if you switch things around like that. Otherwise, though, no, that it doesn't matter which order they come in. Okay. That also reminds me that I didn't. There was one other thing I didn't show you. Let me see if I can call Statgraphics up again. And that is, let's suppose I've done a particular plot. Let me call back up, for example, one of the early plots I did. For example, I did life expectancy, right? And that was a Y versus X. I looked at life expectancy versus year. I did country and gender. Whoops. Oh, no, I didn't do country. It gave me a plot for every single country. There were a few too many countries. It wasn't country that I did. What was it? I guess it was just gender. Let me remember which what I did with that life expectancy. Give me just a moment. I have something I want to show you. Life expect. It was just life. It was numeric. I'm in the wrong Trellis plot. What I had done is I had done numeric Y, life expectancy conditioned on year and gender. Yeah, that's the one I'd done. What I wanted to show you, and this is sort of neat, is that if you have an interesting section, you can double click on it and it expands it. Okay, double click again, it puts it back. Double click, it expands it. Double click, it puts it back. Took a little work to make that happen, so I wanted to make sure that you saw that. All right, do we have any other questions? Let's see. Let me look at the second question. Okay, oh, someone's actually been doing work on looking at the relationship of case rates and vaccination rates by presidential winner. That's interesting. Yeah, I thought that was also an interesting project. Okay. Now, then there's a person saying, how can I get Statgraphics software? I'm a student at National Polytechnical School of Ecuador. Okay, well, we have a special student license that's actually a 6-month and a 12-month license that's very economical. You can get information by going to statgraphics.com, go to the Contact Us page, and it will point you to a dealer in Ecuador. And you can preferably contact that dealer, and they can set you up with a license. As I remember, it's quite economical if you're a student. The various prices. So go to statgraphics.com, go to the Contact Us page. You'll see a list of countries. If you click on Ecuador, it'll give you the address of a dealer close to you that can set you up with a license. All right, well, that was about an hour. I thank you all for listening. Again, we'll put the recorded webinar up on the website here in a couple hours, and I invite you to download the data sets and try these Trellis plots. They are a type of plot that can be very, very useful in visualizing data. Thanks again.